This is a tutorial for the crazy tetrahedron Jupiter. And when I'm solving this one, the first thing I have to do is to reduce, and then after that I have to do everything else normally. So I'm going to mix it up first. This one, it's easy to mix up and turn around because you can always move it, even though it won't always solve. Okay, so now it's mixed up, and the first thing you want to do, as I said, is to reduce. So this one is pretty straightforward. You don't have to really do any algorithms or anything for this. So I'm going to just reduce all of these first, these edge pieces. Just match them all up in all the ways you can. Okay, so now I've reduced all of them, and now I want to put all of the white edge pieces, onto their correct spots. I just have to make sure I don't turn the white side until then. So there's the yellow. So here I have all of these corners, the edge pieces. The corners just automatically got there somehow. It doesn't always do this. And over here. Okay, so now I have all these into their correct spots. And now I want to reduce the corners. And to do this, I have to make sure that these white edge pieces are always here, or else the edge pieces will also be mixed up. So first, just make sure that they're all unsolved, the ones I'm turning. Just match up as many as you can. And then after this, I use two different algorithms for the reduction and for the complete solving afterwards. And those algorithms are to either swap these two and these two at the same time, the corners completely, or to rotate these two corners counterclockwise, clockwise, or counterclockwise, clockwise. So here, I see that there's two unsolved pieces here, and I could rotate this clockwise and counterclockwise. It always has to be clockwise and counterclockwise on two different corners. So from here, if I want to do this one clockwise, this one counterclockwise, I'm going to start with L inverted, R, L, R inverted, times 3, so 2 more times. L inverted, R, L, R inverted. L inverted, R, L, R inverted. And now from here, I want to do the same thing, except the exact opposite of that. So instead of with L inverted, I'm going to start with L. L, R inverted, R times 3. L, R inverted, R, L, R inverted, L inverted, R. And as you can see, that rotated them. Now I just move them over so that at least one of them gets solved. And now I can see that this one is completely solved, and this one is not. So I just want to swap these two pieces so I don't have to worry about this anymore. To do that, I'm going to use pretty much just half of the algorithm I used earlier, and that should swap these two and swap these two. So what I'm going to do, L, R inverted, L inverted, R, 2 more times. So now that piece is up here, and it turns out I didn't have to rotate this, but that one is solved, and I need to solve these. Okay, now I'm going to rotate this one counterclockwise, this one clockwise. Last time I did clockwise, counterclockwise. I'm going to do the exact opposite now. So I'm going to start with L, R inverted, L inverted, R times 3. And then L inverted, R, L, R inverted times 3. And that rotates them. Now I just move this over until I saw this. And this one only has one piece left. So I'm going to rotate this one. This one's going to go counterclockwise, and I can move this clockwise. So the same thing as before. L, R inverted, R times 3. And then L inverted, R, L, R inverted times 3. And now this one only has, this one only has one piece left to be solved. And I can solve that right now, but that won't really be useful because it's going to get messed up later anyway while I'm trying to solve the other ones. So I don't want to keep it in this current state. I want to rotate this one and this one so that I can solve at least one of these. Now to do that, I'm going to rotate this one clockwise, and I don't want to rotate this one or else I'll mess up one of the other sides, and I don't want to rotate this one either. So I'm going to turn this one counterclockwise, and since I don't want to mess up the other ones, I'm going to bring this one down here. That will mess up these two. So this one's going counterclockwise, and this one's going clockwise. L, R inverted, R times 3. And the opposite. L inverted, R, L, R inverted times 3. Move this one back. And that gets us into a position where I can solve these two. This one has one left to be solved, and these two both have one left to be solved. Now I can turn this counterclockwise, this one clockwise, same algorithm. L, R inverted, R times 3. And then the opposite, L inverted, R, L, R inverted times 3. And now I just rotate it once, and I've gotten all the corners reduced. So now for this next one, I just want to have all of the corners mixed up, like in the incorrect position, not rotated incorrectly, just in the wrong spot. These three are all in the incorrect spot, but this one is in the right spot, so I don't want that. So I'm just going to start from here, grab the white and any of these here, and whichever one I decide to grab, keep these three corners in the same spot. I'm going to rotate it once, twice, 3 times, 4, 5, 6, 7, 8, 9, 10 times. And the edges should stay in the same spot, but these should be mixed up. And they are, but this one is somehow got solved, so I just have to do that one more time. And check again, and these are all in the incorrect spots. So now I can use another algorithm, which is pretty much half of the algorithm I used earlier to rotate these corners. And I'm going to first find where this one goes. This one goes right here, and if I swap these two, this one will be in the right spot, this one will be in the right spot. And the algorithm also swaps these two. So this one will be in the right spot, and this one will also be in the right spot. So I'm going to have these two in front, and the others in the back. I'm going to do L, R inverted, R times 3. And now all the corners are in the correct spot. Now I just had to rotate this one clockwise, this one counterclockwise using the earlier method. And that's going to be L inverted, R, L, R inverted times 3. And then L, R inverted, L inverted, R times 3. Now I can just remove this once. That's how I solve the crazy tetrahedron Jupiter. Thank you for watching.